For my Unit 12 project, I'm going to be doing number 5, objective function constraints. And so, first off, what I'm going to start with is graphing my linear equations. So first, let me write them out. So we are going to be looking for the maximum of 3x plus 2y. Okay, so okay, let me go ahead and all right. So our first off, like I said, we are going to be graphing our linear equality. The first thing I would like to do is take our two equations that are given. 2x plus y is less than or equal to 8. And then we also have x plus y is greater than or equal to 4. So what we're going to do is we are going to rewrite our linear inequalities into slope-intercept form. So we're going to take 2x plus y is greater than or less than or equal to 8. We're going to subtract 2x from both sides. Then it's going to give us y is less than or equal to negative 2x. We're going to put this over 1. And I'm going to show you y later. Plus 8. Okay, then we're going to take this equation and we're going to graph it. So we're going to take this and go up 8 on my graph. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8. Go ahead and extend my graph a little bit. 8. And this is going to be my first point. Then down here, we're going to go 1, 2, 3, 4, 5, 6, 7, and 8. Okay. So then we're going to look back over here. We're going to see that I put this over 1 to indicate that I'm going to be going over 1, if that makes sense. So we're going to go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. And I'm going to try my best to draw a straight line. Let's go ahead and do that. Okay, so then we are going to, since it is a less than, we're going to put these arrows going downward. Yes, instead of shading it all at once, I'm going to use these arrows to indicate which way I should shade from this line. And then we're going to do our next equation. So x plus y is greater than or equal to 4. And I'm going to do minus x. So y is greater than or equal to negative x. 1 over 1. Negative x plus 4. So then we're going to do the same thing. So we're going to do this 4. 1, 2, 3, 4. Right there. 1, 2, 3, 4. Right there. All right. So we're going to go down 1 over 1. Down 1 over 1. Down 1 over 1. Down 1 over 1. I'm going to do my best to draw a straight line here. And here. Boom. Just like that. Alrighty then. And then this is greater than, so we're going to be shading upwards. Okay. And so the next thing we are going to need to do is we're going to come back up here, and this is where we're going to use this part here. And so basically what I get from it is that it's saying that, like, of course we know, like, x is equal to 0, y is equal to 0, but it's asking for every every point that is greater than x or equal to x. So we're going to use this line right here. So it's going to be everything going this way. Okay? And then with our y is greater than or equal to 0, it's going to be the same thing, but we're going to do this line. So it's not less than, it's going to be upwards. Upwards. So it's going to be to this side of this line, and in, and up. So this is going to be my feasible region here. This is my feasible region. Cool, cool. And then we're going to use these points here that are our boundaries. Boom, boom, boom. I have 3 that are our boundaries for our feasible region. So here are my boundaries. It's going to be 0, 4, 0, 8, 1, 2, 3, 4, and 4, 0. Okay, so then what we are going to be looking for is these are called our vertices here, right here. These are called our vertices. So basically what we're going to be doing is we're going to, well, our vertices are where our boundary lines intersect. Here, here, and here. Of course, I already pointed that out. But with our vertices, we're going to plug them, our x's and our y's, our x and our y, x and our y. We're going to plug our x and our y here into this equation where it's an x and a y. So I'm going to rewrite z equals 3, 0, plus 2, 4. Z equals 3, 0, plus 2, 8. That's kind of ugly. And then z equals 3, 4, plus 2 times 0. Okay, so anything times 0 is 0. So 8, that's 8. And then 16, and then 12. So our greatest value, which is 16, would be 0, 8. So our the vertices that gives us our maximum is 0, 8, which is this point here on our graph. That gives us our maximum is 0. Oof, my pen gave out. 0, 8. That is our maximum.